can you figure out the next term of this sequence? If you said 13, then you figured it out. This is a famous sequence, a very popular sequence called the Fibonacci sequence. And if you didn't figure out 13, I'll explain how you do it. You take the two previous terms and add them. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, etc. So that's why 5 plus 8 gives me the next term of 13. So if I wanted to find out the 10th term, what would you need? You would need the 9th and the 8th term. And that type of sequence where you need a term before it in order to figure it out is called a recursive sequence. And we're going to look at what are called recursive sequences in this chapter, or in this lesson. You've written these things called explicit equations. Explicit formulas base all the terms on the first term. So if you think about arithmetic and geometric sequences, we were always basing it off of our first term. When you base a sequence off of just any generic term, any random term number, and you use that term to get the next one, it's called a recursive formula. So you know these formulas for arithmetic and geometric, and then there are these new formulas, recursive for arithmetic and recursive for geometric. So what we do is we take our ratio or our difference, depending on whether you're talking about a geometric or an arithmetic, and you add it or multiply by the term that came right before it. Now, what I want you to understand is that a sub n minus 1 does not mean distributive property. It's not saying take an minus a1. This is saying, remember when it's a subscript, it's saying that this is the term that came right before the term you're looking at. So a sub 3, I'm sorry, not a sub 3, a sub n minus 3 would be looking at a term that came 3 previous to whatever you're looking at. A sub n minus 7 is talking about a term that came 7 terms ago. So let's write terms of a recursive sequence. So in the first example, our first term is 2, and then we're taking whatever term came right before the term we're looking for and add 3. So this whole crazy fancy formula just means that you start off with 2, and then each term is found by adding 3 to the term that came right before it. So 2, and then the next term would be 5, and the next term would be 8, and we have to find the first 6 terms. So I'll just rewrite those. I'll do number and term. 1, 2, 3, 4, 5, 6. And my terms were 2, 5, 8, 11, 14, 17. So can you please pause the video and graph letter A down here? So check your graph, and I guess I should technically label it a sub n equals a n minus 1 plus 3. Now you might say, wait a second, why can't I just write that as the equation y equals 3x minus 1, because that would be the equation. And I like your thinking if you thought about that, but we're not quite there yet. That's going to come in a later example. Let's do the same thing for letter B. We have to make a chart for our 6 terms. And in this case, it's telling us that each term is found by multiplying the term that came previous by 3. So this says 3 times the term that came right before it, because if I'm looking for an, then a sub n minus 1 is the term that came right before it. So 1, 2, 3, 4, 5, 6. It tells me that the first term is 1, and multiply every term by 3. And when you're ready, pause the video and graph. So, oops, plotted off the grid just a tiny, tiny little bit. But here's my formula, and there's my exponential graph. So now we took some terms and made a graph. Now we're going to take some terms and write the rule. So first thing that you have to do is determine which rule you're talking about. Are you talking about arithmetic or geometric? Because there are two different formulas which you have written on your paper, but I'll just write them on mine because they're not on the screen. The arithmetic is a sub n equals a sub n minus 1 plus d. And then the other is a sub n equals r times a sub n minus 1. So you have to know which formula to use. So you have to figure out whether you're arithmetic or geometric. So you should be able to look at this and say the common difference is 12. So I'll write that down, d equals 12. And that's all you really need to write the rule. So a sub n equals a sub n minus 1 plus 12. Done. And that's a recursive rule. For this one, it is a geometric. The ratio is looks like 1/5. So take your formula. A sub n equals 1/5 times a sub n minus 1. And that's the recursive rule. Now, you also need to tell the person what the initial value is because, yeah, it's plus 12, yeah, it's 1/5, but if they don't know what the first term is, then they can't write the rule. So let's go back and let's add that the first term is negative 30. And here the first term is 500. So that's also very important to add when you're writing the rule. Another thing that you can do with recursive rules is turn them into explicit equations. And remember, we had two explicit equations for arithmetic. It was a sub n equals a sub 1 plus n minus 1 times the difference. Or for geometric, it was a sub n equals a sub 1 times r to the n minus 1. And the difference between explicit and recursive is that explicit is based off of the first term, where recursive is based on the previous term. So we're going to use our formula. You have to know which one to plug in first, and then we can translate it. So in letter A, the setup looks like an arithmetic sequence because you're subtracting 10. So that would be like, for example, that is the common difference. So I'm going to plug in what I know into the explicit formula. A sub n equals, well, instead of A1, I will put 25, and n minus 1 stays n minus 1, and the d is negative 10. So you can leave it like that, but it's preferred for you to distribute and simplify. So a sub n equals 25 plus, well, when you distribute, you get negative 10n plus 10. So I will simplify that. A sub n equals 25, 35. Minus 10n, or negative 10n plus 35. It doesn't matter which one you prefer to write. Let's do letter B. We're going to plug it into a formula. This one is being multiplied, so I'm going to use the geometric formula. So a sub n equals, well, A1 is 19.6. The common ratio is negative 0.5. A lot of decimal points in this question. And n minus 1 goes right there. Now, you can't really simplify that because you can't multiply these pieces because exponents would come first. So you can leave it like that. I'm just going to get rid of all my dots. as best I can. So a sub n equals 19.6, and I'll just put the -5 in parentheses. You don't have to change it if you don't want to, but I prefer to. And so that would be what I would write as my formula. Last one is doing the reverse, taking explicit and turning it into recursive. Now remember, for a recursive rule, you have to know what terms came before it. So we have to do a little bit of work in order to use our recursive rules. So let's find just the first two terms. So we'll find n, and then we'll find the number. So if n is 1, then I plug in 1, and I get 1 as my answer. If I want to find the second term, that would be -1. So what is the difference? Because this is set up like an arithmetic sequence. The difference is -2. So now I know the d, and now I can plug it into my recursive rule. So a sub n equals a sub n minus 1 minus 2, or plus -2. I'll write minus, just so I don't have to write too many operations. And remember, you want to keep that n minus 1 as a subscript. Keep it lower because it's not a value. It's not an integer. And for letter B, let's do the same thing. If you can find the first two terms, then you can find the ratio. So if n is 1, that gives me -3. If n is 2, that gives me -6. So how do you get there if this is a geometric sequence? And I say it's geometric because it's set up like geometric, and I'm used to seeing that at this point. It looks like it is multiplied by 2, so the r is 2. So let's plug it into the recursive rule. A sub n equals 2 times a sub n minus 1. Now, when you have recursive rules, again, like I said in example 2, you need to tell the person where to start. In explicit sequences, you can start at 1, n equals 1, and plug in your values, but because recursive rules depend on the term that came before it, you have to at least tell the person what term to start with or what the value is. So I'll start off and I'll say that the first term here, in this case, I got it was 1. And here, my first term was -3. So you always have to add those when you're dealing with recursive formulas. It doesn't hurt anything if you write it with an explicit, but it's necessary for a recursive. All right, last thing is to look at sequences that are not one of the two that we've learned about, not arithmetic, not geometric, and this is the sequence that I introduced you to in the beginning of the lesson, which is the Fibonacci sequence. So how did I find the next term? I added the two terms that came right before it. So that would be, if I wanted to find any random term, I would take the term that came right before it plus the term that came two before it. So, for example, if I wanted to find the fourth term, which would be right here 3, and is 4, I would take a sub 3 and add a sub 2. So that would be a sub 4, which in this case would be a sub 3 plus a sub 2, and you see you get 3 as your fourth term. So now that you have the formula, you found one term back in the original example, which was 13. Now what are the next two terms? So 13 is one of them. Find me two more. If you have any questions, write them down and ask me when you come to class.